So hey guys, welcome back to another video. Today we will be talking about this problem known as chocolate distribution problem on GFG. Okay, so what does the problem state? Let me just first write the topic. Okay, so what does this problem state? So let's assume that we have an array. Okay, so let's assume we have an array A which have the elements 3, 4, 1, 9, 56, 7, 9, and 12. So what we want to do, we want to and there will be m, which are the students, right? So let's assume we have given that we want to distribute this chocolates to three students, right? So how do we distribute this chocolates such that the difference between the starting element or starting chocolate and the last chocolate is minimum? Okay, so let's assume that we take these three consecutive elements, and the difference between 9 and 4 is of course 5. So how do we minimize this difference, right? So how we can approach this problem? So let's check how do we approach this problem. Actually it's 5. Okay, so we will do m equal to 5 as the problem has stated. So we will do m equal to 5. Now how do we approach this problem? The optimized approach that we can use is, what we can do, we can first sort the array, right? So we get the minimum difference between the first element and the last element in this range, right? So we can use quicksort. Like we can take the pivot element and ing or low or high element high pointers, and or else what we can do, we can just use an inbuilt function which is provided in JavaScript and Java as well, which will sort the array. So after sorting, how it will be, it will look like something: 1, 3, 4, 7, 9, 9, 12, and 56, right? So this is a sorted array. Okay, so this is a sorted array. Okay, now we want to have a so what we will do, we will start our I pointer here, and we will check till n minus, so let's assume that the length of this array is n, and we will run this loop till n minus m, which is 5, right? So 0, let's give these indexes: 1, 2, 3, 4, 5, 6, and 7, which will be 8. So 8 minus 5, which will be, it will run through till 3, third index. Okay, so it will run till here. Okay, so let's assume that first it will calculate 1, and for we can what we can do, we can do 1. So what we can do, we can do I plus m minus 1. Okay, so how it will work, we will, for a last index, we will just use this, and let's assume this is the array. So array of I plus m minus 1, which is the index plus the range that we want, which is 5 minus 1, because of course it starts from 0, so that's why. So I plus m minus 1, we will do, we will add, we will decrease the array of I, right? So the starting index, right? So what will be array of I plus m minus 1? So m is 5. So this is 0. So 0 plus 5 minus 1, which will be 4, right? So it will be moving till here. So we will take the difference between 1 and 9. So what's the difference? The difference is 9 minus 1, which is 8. So it will return 8. Okay. So we'll update the, there will be one more there will be one more integer that will be storing, that is min, or whatever we say, min difference, right? Initially we will just store it with max int. Okay, and after that, if min difference is less than this, what do we say, this difference that we got, let's assume this is the variable difference. If it's less than, then we will update the min difference. So we'll update it to 8, right? Now we will check for 3 and this 9. Okay, so now the difference will be updated to 9 minus 3, which is 6. So this will be updated to 6. This will be 6, right? Then we will move to 4 and 12. Now what's the difference? It will be 8. We won't update this. This will be updated, but we won't update this. because 8 is of course greater than 6. I'll move to 7 and 56. Okay. So this is will be 49. We won't be updating that as well. Okay. So let's this is the output that we'll get. So we will just return the min difference, right? So min difference, we return that. So that's how this chocolate distribution problem is done. Let's go to the code. Okay, so as you can see, here also we got the output as 6. Okay, so that's how we do that. So here is the min difference value variable that I was talking about. So we will store the max value. We will sort the array using the inbuilt JavaScript sort function, which I guess uses a quick sort, or I'm not sure. It uses some optimized sorting technique, and we will run this loop from 0 till I plus m minus 1 is less than n. So we'll run this loop till I plus m minus 1 is less than n, which will be initially, and we will do I plus plus, okay, till this value is less than n, which n is the length of the array. We will calculate the difference, which will be ARR of I plus m minus 1. So we'll add I plus m, which is the range which we want, and minus 1 because the index start from 0, and array of I, which is the initial element. And if the difference is less than minimum difference, we'll update the minimum difference and return that minimum difference. Is giving the expected output. Now if I submit this, okay, so the problem got submitted, and yeah, it worked. Great, thank you.